Brandon.
Hi there, Marcin. Leonon, did you manage to pass the human check yet?
Oh, in the survey, I didn't try again.
I honestly, when I saw that option, I was like, that would be fun to click. And then when I remembered you didn't get it to approve, I'm like, I could really see you clicking that button.
I mean, like, I think their targeted audience for their survey is going to have a higher than average likelihood of choosing that option. Like,
Yes.
the people they want to answer this survey are the people who are going to choose that option.
The
They
people that
they
wrote the
should
survey.
switch the validation.
Yeah.
Yeah, like, that's what you're about to say, isn't it?
Yeah. The people that wrote the survey are not the ones that are thinking along those lines. But absolutely, when I saw it, I was like, oh, I want to click that one, but I know what they're asking. Whereas in the survey line, I think was I'm just a bunch of lines of code or something along those lines.
I see.
Yeah, apparently you were supposed to choose the option, I'm a human. But yeah, they gave options like I'm a robot, beep boop, and I'm just a bunch of lines of code. With another option of I just want to mess with the researchers, which, given those four options, I'm a bunch of lines of code. I'm not a human person.
Well, I cannot say you are not a robot. I never met you.
I mean, you can tell from his profile picture, he's got all the right, angles.
How was your meeting, Brandon, with this Edge devices group? Because last time there was a request that somebody talks to them about Edge devices use cases running Kubernetes on Edge, and you were volunteering to meet them, right?
Oh yes. Yeah, the name of the group. Margot was it, I think, or Mango? I got it written down here. Margot. Yeah, that's another one of the LF projects they're working on, and they've kind of got a vision architecture what they're looking at, and they were just kind of getting a little bit of feedback. I've been playing that space a lot over the years, so I think I gave them a whole bunch of thoughts of stuff they need to work on or consider. But I was a little bit all over the place with different thoughts because it's how do you get the image to the edge? What are they putting in an image? Because they were talking about where do they store their configuration. And I said, well, the GitOps is the popular one today, but GitOps is also starting to allow the data source to be an OCI registry, at least some of the GitOps tooling. And so you can point, I think it's Argo, you can point directly to an OCI registry. So
Cool. I know I'm boring, but were they interested in image compatibility?
I pointed them over to you just because of some of the stuff they're looking at.
Because a Kamaili node, they were kind of interested in that as well.
Yeah, I point them your direction or to the meetups, to our other meetings direction, just because of some of the stuff that we are doing, has a lot of overlap with some of the stuff that they're doing. So not necessarily image compatibility that they would be interested in, but I think some of the people in that group are going to be able to have some good input for them. So I wanted them to make some connections there.
Nice.
All right, well, looks like we got a decent gathering here. Just kind of tracking all the folks that are coming in. And let me, this one, okay. So that should be sharing not that window. That window. All right. So kind of got the items up here. Zoom is doing all kinds of weird stuff to my mouse. Sorry about that. Cannot adjust certain things right now. But this one came up a little bit this past week, even though it is from back in 2017. The idea behind this request was, hey, we've got a bunch of this validation code going on that says to show some stuff to standard output for warnings when you do validation on the image spec. It's things like if there's a platform that doesn't know, it throws a warning and it throws that to standard out. The validation doesn't fail. No one's really checking that. And so this way back in the day was VBAT saying, hey, what should we do about this? The thought I had at the end here, because this kind of got brought back up again, and there was a suggestion of, hey, there's like a whole bunch of different ways we can do it. The one I was leaning toward was, should we go with an option of adding another method that's just validate with ops, make an ops struct in there that just has different kinds of validation you can do, or different settings to put on the validation, and have maybe a strict mode or something like that. And then the normal validations already there can just be a pass through this with all the default ops. So I wanted to run this by the group, see what the thoughts were, if that was something that made sense to others, if I should work on a PR that did that. If folks are not even imagining what on earth I'm talking about, feel free to raise your hands. I can also go over to the code, give you an
Does
idea of some.
this validation code have any importers? Like, I guess I'm trying to find a nice way to say, is anyone actually even using this code?
I don't know if we can check at this tier, can we? Can we see if someone pulls in image spec schema and
We should
calls
be
the
able
validate?
to, at least for public importers on package.go.dev.
Because I know you can tell who has imported the image spec, but I don't know if you can tell who's imported image spec and is using the schema package within there. If you've got a link for that, that would be awesome.
Yeah, I'll dig it up.
Because right now we've got is just a regular validator method that passes a reader, and this is what we've been reworking with the latest PR about swapping out some of the libraries in here. So the idea is take this, make this a stub that just calls validate with options, and then pass a couple options in there. Because when you get down into some of this, we just output like the validate of a bunch of those are errors, but then we've got a bunch of printfs of saying, hey, this thing doesn't look right to me. Another printf warning that architecture isn't supported for the platform in here. Combination of OS and architecture isn't valid. Now, perhaps we don't want that, but maybe let's see. It's got a few links here for us. So
That looks to me like it's all either forks of the image spec or forks of the image tools.
okay. So not a lot of people using it. I'm not using it.
And the image tools haven't been touched in 3 years.
Yeah.
I don't know if anyone's using those. That's even harder to search for.
Even this list down here, I
Yeah.
would be surprised if people are really using this.
You know,
So are you saying don't even bother because no one's using it, or are you saying we can change it because no one's using it and we're not worried about breaking anybody?
probably more of the former than the latter. The best code is the code we don't have to maintain.
Yeah.
And so the end result of that axiom is the best code is no code at all.
So on that note, I was considering when I was going through doing some of the rework, flat out deleting this. It's called internal, it's not an export function. And its only thing is a side effect of a format printf. And similar up here, same idea.
Amazing. Nothing but a warning to standard out.
Yeah.
It doesn't even take a writer to write the warning to.
Nope. And so for those kinds of things, I'm thinking just delete it. And if someone screams, then we can work on figuring out how to get it back later on. But nobody can call this directly. The only way they can call it is to call our other validation functions and then look a standard out. I mean, the other option is to maintain some code, but I definitely see your point there, Tianon, of the less code we maintain, the better.
Yeah, let's write a new module that looks better is if we build it, they will come.
Potentially.
Maybe.
Potentially not.
Maybe not. Maybe we'll have a new set of code that we now get to maintain in perpetuity.
I was just looking at the containerd platform parsing code this morning and thinking, yeah, I should have looked at that earlier. And that was one of those things that I rewrote myself, and I didn't do exactly the same. And apparently people are seeing different behavior within Docker depending on where they're calling it from, what version. Thinking, yeah, a lot of us keep rewriting the same code.
Yeah. So what I'm trying to prevent is the XKCD here of, wow, there's a lot of people writing this code. Let's write it one more time. Except now there's just one more implementation and no actual standardization, centralization.
Not to mention, if we write, we must maintain it.
Yeah. I know for myself, I've written a lot of code that interacts with OCI images and artifacts. And the only reason I ever import the image spec is to get those structs so that I can have the canonical structs maintained in the image spec.
Yeah, not even the schema go, but the specs go.
Not even the schema go, nothing else, just the structs.
Yeah. Makes sense to me. Sajay, I think you've been thinking about this a little bit. I saw you chatting. Any thoughts there?
No, I think we went through this conversation of platform. Once we encode it here, it becomes maintenance nightmare. If new platforms come, we have to update this and whatnot, right?
Yeah.
Yeah, and a printf is as useless as, I mean, there's nothing we can act on. So,
I didn't even know there was a dragonfly. I need to start Googling some stuff.
I mean, is there an example? Are there a set of examples that we put out there somewhere in the docs?
I'd have to dig. Don't know off the top of my head. But I feel like, at some point you were adding in, when we were talking about adding ARM 60 or AMD 64 variants to put like a V123 in some other places. And we
It's
didn't update
already
this, but
it's merged in the spec.
yeah, but not in this file.
Yeah, because this is unmaintained. This is code that is not maintained and has not been for a while.
And nobody looks at.
And nobody uses it.
Yeah. Or if they did, that print to standard output is not looked at. So Sajay, is this kind of what you're thinking of to document at this level?
Yeah, exactly. I mean, if we have this, then it's not much, then the check is kind of, yeah, less code, the better, right? In the end,
Yeah.
especially this repo.
All right, gives me one more PR to make. If folks are good with my other PR of changing the validation, I think we were talking about that last week. If we merge that, I'll go through and do this other one to clear out a couple of these things. Any other thoughts on that one before we jump to some of the other items here? Thumbs up from Sajay. Okay, so I think next on the agenda, stop my share. Marcin, I'm guessing you put a little quick item there to chat about.
Yeah, image compatibility proposals again. I know I'm boring and pushy, but we are blocked in the working groups. I want to unblock us, and I wonder if Tynon or Sajay, Derek, you had a chance to watch the proposals video.
I want to echo what Samuel kind of like mentioned in a meeting. Is the working group blocked because of building consensus within the working group? I mean, we want to avoid it like members of another group need to influence or unblock people within that working group. It's just from a healthy standpoint.
So I would say we have some kind of consensus in the working group because we came up with 2 solutions, and you would like to hear more input from maintainers, especially from maintainers, about the proposed solutions. We have basically 2 use cases to improve the container runtimes image selection to be more granular, and all other use cases where container runtimes are not involved. That's why we want to put compatibility metadata into artifact, which might be controversial for some people. And we would like to hear more about this opinions if, for example, this artifact is acceptable from point of view, because it would mean we maintain a new spec kind of under OCI, which is not difficult spec. You have a list of compatibilities, but the idea is that you come up with a list of known, well-known labels under OCI. So, for example, you would have OCI CPU features, OCI CPU vendor, for example, some kernel aspects like, I don't know, OCI kernel modules, and so on. And the reason why we don't want to put this into image spec is that we are not limited by the image index, and you have a separate entity under artifact. More about that, why we want to have artifact. Here is the artifact justification link to express some kind of opinion about that. And also you can put some kind of context into compatibilities. For example, you might require different compatibilities when you are you might have different requirements when you're running stuff on Intel CPU or AMD CPU or many different use cases, to put some kind of context where you have a list of compatibilities. So if you didn't have a chance to look at that, would that be a good idea if we organize or we hijack half of the meeting the next week or 2 weeks from now, where we go over these proposals again, introduce you in 10 minutes, and then we can discuss? Because I understand people might be busy and don't have time for that, but we have to find some kind of solution for that.
I think
Maybe
that makes perfect sense. I don't see anybody else hands raised, but I would recommend like specifically runtime spec maintainers be in there. And just get an overview on the agenda. I mean, the point is, if there's nothing on the agenda in this meeting, please, I would recommend put it on the list, unless others have any other opinions on that.
So I will try to gather a bigger audience, more maintainers, and let's just discuss this on OCI Weekly.
Yeah, sure. The other thing is, it would be good to maybe open an issue so that people who cannot attend this call can at least take a stab at the document and then see if there are any concerns.
Yeah, good idea. I will open an issue. But the question is where? Image spec issue or under open containers TOB?
Where do you plan to send the PR for the updates for this one? I'm thinking it's image spec, given that it's a compatibility update, right?
Yeah, so for
Potentially a new spec.
potentially a new spec, yeah.
They want to, I mean, is it an addition or is it a change to the schema? Okay, let's discuss the thing in detail. I think
Marcin,
Okay.
hijack. Just go for it.
that's probably easier.
So sorry, could you repeat the last?
Just hijack right now. Don't even
Okay.
schedule anything else. Just go for it right now.
Okay, let me share my screen then. I'm gonna show you what I
Yeah. Well,
have in here.
while you're pulling up the screen share, I think the big concern is we've got a single maintainer that's in there, myself, that's attended that meeting, and we want to make sure that, I've been looking at it from the runtime side of image selection, but we've got a lot of other people in there that are looking at it from the other direction of how do we do this for provisioning and other kinds of challenges. And they've got big visions, and we want to make sure that we don't go through this whole process in the working group and then get to the end and then come back to the OCI, TOB, and maintainers of other groups and say, hey, here's what you were working on all this time. And them saying, well, we're not interested in that. And why don't you tell us that you were going that direction? We'd like to get feedback sooner rather than later.
Yeah, exactly. So speaking of the artifact, so the idea is that we, of course, come up with new artifact type, which is OCI image compatibility, and we create a new media type for compatibility specification, which is attached as a layer, right? Then we want to associate images with artifact over subject field and do the discovery over reference API. And then when it comes to specification itself, we want to create a new kind of spec, not kind of new spec under OCI, where you would have list of compatibilities like described in here, and over one set of compatibilities can be, for example, provide some kind of context over tags. So as you can see here, you can describe different set of compatibilities over for Intel and different set of compatibilities for AMD. That's use case for telco, very common use case for telco, or for HPC. Probably they would shape that differently. However, you have a possibility to put context over tags. And we would like to come up with well-known labels under OCI. The process how to add those labels under OCI would have to be kind of created, or we have to come up with that. We don't have this yet, how the process would look like. But the idea is that we have a separate entity where you put all the metadata. So you can put some additional context. And in case of artifact, container runtimes are not involved at all. We don't want container runtimes to download artifacts for image selection. This is the use cases like, for example, cluster provisioning, grouping applications. We want image authors to build kind of one single point of truth for their images. Like, I know my images require this specific PCI devices. I will put that into the image compatibility artifact, and every consumer will be able to pull that. In telco, for instance, you have use cases where you have vendor that come up with some specific application like router, and a lot of telco companies consumes that. So to make easier the whole provisioning of the cluster, adjusting the nodes for some kind of good performance, or that those containers can even launch on the host, we need to define these compatibilities, and we would like to make it in more unified way and more programmatical way. So in this scenario where we have artifact, container runtimes are not involved at all. And then we have some kind of justification why not to put in the index, like, for example, introduce a new field, compatibilities, and put everything in there. We think here about the size limit. We don't want to put a lot of mess into index itself, because manifests can have duplicated entries, and also the size of the index will not rapidly grow. And maybe we could release this first as an experimental thing, and then last we can attach this to already released images. And the questions to that?
I think I've got a couple of thoughts here with different hats on. With my OCI hat on, I don't love the idea of another spec or of an additional schema for the OCI to maintain. Especially because traditionally we're not super great at actively maintaining these things, but also because this seems like a small thing, not a large thing. And if it's a large thing, then maybe we're missing a use case somewhere. Okay, so OCI hat off, Docker Hub hat on. I don't work on Docker Hub, but I work for Docker. I don't think Docker will appreciate extra requests for every single image just to validate whether it's compatible. Like to pull this extra artifact object on every single image pull to verify whether or not it's compatible while just doing image selection, like it pulls the index and then it pulls an artifact for every entry of the index to try and choose one. Not
Let me interrupt you here. As I mentioned, this artifact is not for image selection. I mean, if you would like to cover like some, for example, Docker, checking if the image is compatible, we have different proposals introduced by Brandon. So
if this isn't for image selection, then I've completely misunderstood the point. What problem are we solving?
Basically, somehow you have to define, like we would like to create some kind of single source for image authors and everybody else to know or share the containers requirements. Because typically how it works today, you assume your containers will work everywhere, right? And in telco case, it's not true. Also in HPC. So for example, if you require any specific kernel configuration or specific accelerators or something like that, you know that your container will require that, then you have to define this metadata somewhere. And we thought to create for that a separate artifact entity. It's like, for example, if I have a 6-win router, let me find that. You have there a lot of required kernel configuration or capabilities enabled and so on. So today there is no way of describing those things in standard way. HPC use case is the same. So we just want to, for example, if you are building 6-win router image, you can put what you require for container and later let somebody or some tool to download these requirements, maybe do some dynamic reconfiguration or whatever based on your use cases. But it would provide you more programmatic access for requirements, not only the documentation. Does that make sense to you, or should I elaborate more about that?
No, that helps clarify. Thank you. So from an OCI perspective, I think the appropriate place for this data would be annotations or the image config, frankly. Because the image config is how to run the image and how, like what the image needs at runtime kind of data.
I'll give a different perspective or a different way of phrasing some of this, which is that we've got the annotations and the index right now that we're proposing for the image selection. And some of the challenges they're looking at is cluster provisioning, things kind of like the image version of what the node feature discovery does. And so you've got node feature discovery, I'll tell you what hardware you got out there. You've got something in the container image that'll tell you this is what the container image does. And then the merging of the two of those could potentially be used by a scheduler to figure out where does it want to try to run this image within the cluster. They're looking at different level issues. Does that make it clear or more confusing? Guessing I just confused you.
Yeah, I think that makes it more confusing because now you're talking about image selection again.
So
is this image selection or is this image requirements?
From the scheduler versus from the runtime. So think of a cluster scheduler, not a container runtime.
Yeah, so for the artifact case, it's about the image requirements. I would put it that way. Maybe it makes sense, Brandon, if you also show your proposals that people understand these two ideas that we have. Use cases where image selection are not involved, like this artifact way. This is only about image requirements and how we want to improve the image selection.
Sure.
At the beginning, we thought about annotation, but annotation is just a map string, right? And it would be difficult to put some additional context in there. And also, you would have a lot of duplicated entries in the index. I understand index annotations, right?
Yep. You want me to share the proposal?
Yes.
So this was the one that kind of was me thinking probably along the same lines of what you're thinking of, Tianon, which is that we can go in and have an extra annotation and add that on wherever we need to. And then the thought process behind this was that runtimes could be told, as I provision or as I deploy this instance of containerd or something out into my cluster, on these nodes, I'm going to put a preference for a certain annotation on this instance of containerd. That'll be injected as a configuration. It wouldn't be something that containerd needs to know, but it'll be a user configuration of the containerd process, something in the YAML file or whatever, or in TOML file. And then these prioritizations could be ranked, they could be scored along those lines so that they're multiple, they can be added together and sort out some kind of priorities of, oh, I really like this GPU, this other one will work good enough for me or something along those lines. The rest of this was all boilerplate. There was a second version. What was my other one? Was it F or E? Guess it was E. Yeah. When we were talking about this, Derek, I think you were in there, and I think we had Steve-O in there as well. And the question came up, well, hey, there's already an existing features field today. Why don't you use that? And so there's a second proposal that's kind of alongside of A, which is saying we could use the features. Initially, that's going to be just CPU features. And the difference between the annotations and the features is that the features are very much a runtimes know how to parse this already. They'll be coded into there. You're not configuring the runtime to look for this. There will just be something that containerd will be upgraded to look for. And if it ever sees it, it's going to be a hard requirement, not a soft requirement. And so with A, if there was an annotation it didn't recognize, it would just kind of ignore it and keep processing the record just like everything else. With features, if it sees something it doesn't know how to work with, it doesn't know what that CPU instruction is, it's just going to flat out reject trying to even deploy that image. It'll go looking for another one, or it'll tell you it doesn't find anything it matches. And so that's kind of the high level difference between the two, is that this is a very much a hard requirement on stuff that the runtime can be programmed to look for versus a soft check on something that the runtime can be configured to use if you wanted to. So this is image selection at the runtime level, which is very different from a lot of the annotation discussions we've been having, or sorry, the artifact discussions we've been having for how can we do something at a higher level than this. Chat goes wild. What's happening over there?
But both these proposals were revolving around modifications to the index and not an extra request or a new artifact or anything like that, right?
The A and E that I put out there were both on the index, correct? It's not a new artifact. It's not anything external. It was very focused on try to keep these minimal. We don't want to blow out the manifest size limit, anything like that.
Right.
They were trying to be fitting logically with whatever is already out there today. The artifact work that everybody else is looking for, and this is why they keep coming to you, is because the proposals I'm putting out there are saying, hey, we're just going to do this. And they're like, that's great, but we got these bigger, grander schemes out here. And I say, well, that's a little different than what I'm looking for, but let's make sure the rest of the maintainers are on board with what you're doing so that you don't go too far down the path without getting the other maintainers, some kind of buy-in from somewhere in OCI.
Yeah, and I'll be very honest. I'm definitely a fan of artifacts, but I don't see the value here, like in the sense of the majority of the use cases for artifacts were you don't want to mutate the image, you want to attach something to it but is there a use case of this being a mutating state or features being added along the line? Otherwise, adding an extra request overhead to the registry is already going to be a problem. I mean, we're seeing this request overheads and throttling and all over the place. So it doesn't matter whether it's an artifact or an image. Either way, the request count will increase significantly if we want to add just one piece of metadata. So I think weighing what is the reason for it being an artifact needs to be clear, and if we are doing the proper trade-off.
Yeah, I mean, for the artifact, I personally maybe don't care too much where we put this metadata, if it's artifact or image spec, the index. But if you put everything in the index, I'm afraid that you will end up with multiple entries being duplicated between image manifests. Because I can have, for example, version 121 of some image, version 122, and I will copy metadata between each other, right? So you have a lot of extra metadata in the index itself. And if we are suggesting to use annotations for that, the situation will be basically the same. That's why we came up with the artifact, that if you want to download this metadata, do it yourself over some tools. Don't expect that, for example, container runtime will download that or so, if that makes sense, what I'm saying right now. It's just artifact was sound like good place, at least right now, to put optional metadata that describe container requirements. But if you're saying image spec is a better way, and we accept that the size will be higher, and then it's fine by me.
Can we talk about how does this, like, I think Diana's question was probably pretty important. Are we looking at this on a discovery on a infrequent basis, or are we looking at something that this request is going to happen every time somebody does a pull of anything?
No. This request will be very rare. It's going to be in our use cases, and I think HPC use cases as well. It's gonna be before you run a container. Like if you want to provision the cluster or you want to fit the scheduler. So I would expect that this kind of request to artifact, just to fetch this artifact, it's not gonna be common. It's hard to judge right now with or provide you numbers, but so for example, if you have a telco use cases where you have a sysadmin that wants to know about the requirements before he runs the container on the cluster, he just pulls the artifact once, prepare the cluster, or verify if the cluster is capable of running this container, then run container on the cluster, and each time you just pull the image itself, you don't pull the artifact. The problem is because telco is right now moving from virtual machines to containers, and a lot of telco companies are interested in that. There is the Silva project that unifies telecommunication companies in Europe, and they have a problem because they don't have a standard way of describing these container requirements. Also, HPC guys, they have the same problem. So we realized we have a common use case in here, and other things like other organizations as well, like Kata containers. So we thought we maybe can create some kind of standard under OCI for this, how people can describe image requirements. For instance, for those who doesn't know, HPC was putting all of this information in annotations already. For image they put some labels to describe their the requirements. Yeah. But artifact itself is just one part of the story. The second part of the story is OCI well-known labels. What do we want to put there if we want to define some kind of standard for that? HPC guys already complained that there is no standard way of describing that. They had attempts to do this on their own. Like Christian from our working group, he came up for HPC with some idea of standard known labels, but this was only for HPC. Telco needs that as well. So yeah, That's why the working group has been created.
Anybody else wants to jump in?
Yeah, this is a tough space. It's a very tough space. The reason people are using labels is because they want to extend the capabilities of the system to do filtering, right? Customization. But these labels, yeah, they're really ad hoc. They're not meant to be generic, definitions that everybody has to implement on every platform, or otherwise they'll get, not those containers won't be switched to that node, right? So that's one thing to think about. Another is, while your one admin's requirement that the GPU device should be of this type and be available, those applications that are running in those containers generally already have code to do a switch on. If the device is available, it'll take advantage of it, right? If it's not, it'll drop to the CPU, for example. Okay. So when you have these requirements, you sort of have to say, is this a hard requirement or a nice to have? Who's going to evaluate which host to run these on, right? And the reason I'm mentioning this host kind of thing is because we're currently going through this set of scenarios for DRA, and DRA not in the ad hoc way where you would handle generic classifications like generic annotations and then parse them later on and make it be host dependent config. No, what they're doing is they're trying to make it more specific, so that when you make your DRA class definition, it's for the particular device configuration that you wanted. And those would have to be made available a priori. And the reason for that is because Kubernetes scheduling has this dependency on knowing what the hell it's doing with regard to deployed nodes, having particular pods running on them. And do I need another node because I'm already using the allocated resources? Okay, so what does it mean to allocate a resource when it's a label?
Yeah, you're right, Mike. But I think about this problem in a little bit different way, because DR is very specific about this, how you bring and what kind of GPU you are bringing to your container, right? In our case, we just want to say this container requires GPU. If you have a use case that you need a specific GPU model or something like that, you could be as specific as you want. But we don't want to keep like different contexts of configurations that users can put there, because this is a chaos and it will explode.
Got it. So you've got a what if I have an application that can't run without a specific piece of hardware information, this being reported all the way up from the device layer through to the container runtime, and in the Kubernetes case, back to kubelet, and then back to this scheduler so that it knows not to run that pod again on this node because that resource doesn't exist. I think that's the pattern you're talking about. And yeah, we've been talking about this since forever. We definitely need some way to have a device reporting or capability reporting, system going back up so that people can make better decisions on whether or not they should try. Because if you've already loaded up and run half the containers, and then you find one container in a pod that's not going to run, now I've got to start over, and don't please taint this node now. But that usually doesn't happen in the field. Clouds get configured a certain way, on-prem servers get configured in a certain way. The containers they use and deploy, or the pods they use and deploy, are well known and have already been pre-tested. There's not a whole lot of dynamic, discovery going on, at least not in the cloud space. And then on a client where the user is trying to do this kind of scenario, again, he's going, oh yeah, I guess I don't have that device. I can't run that container because it says in the list of dependencies in the header declaration of the image, it says I've got to have all these things configured. I got to run this operator, and that's going to set these devices up, right? Which is the current pattern we use. Run an operator, configure your devices the way you want them to run these applications.
Yeah. So
Just,
basically,
I'm just saying.
no, that's cool. That's cool. Because we think about, at least I'm thinking about image compatibility as minimal set of requirements for the container that it can run on the host. We don't want to put there lots of users configuration. It's just if you say your container requires GPU, just put it into compatibility. As I require some GPU. We don't care how you provide this GPU or there and on your
Okay.
container or what kind of GPU is that if you don't have such a requirement, right? So yeah, it's just to describe the minimal requirements.
Okay. So an NRI plugin for filtering containers based on some additional spec information that's available either as a label or as another platform matching field.
Yeah.
We could do that as a plugin and experiment a while and see if anybody's interested.
So to
Sorry,
kind
Brian.
of look at what you're asking about, Mike, and also Sajay has been in the comments asking similars, a different angle from the same answer kind of here, which is that if you are the Kubernetes scheduler, how far down do you want to dig to find out where you can run this stuff? Do you want to be forced to pull the index? Because right now I don't think they pull the index. And so you would have to pull the index and then do some check there. Do you want to pull an artifact for this? And that artifact would be per platform listed in the index, potentially. And then to Sajay's comment, should this be an extension of the config? If we're doing it at the Kubernetes scheduler, that would be pulling not the refers, but you'd have to pull the image config for each entry in the index to figure out, hey, do I have the right fields in this config that I can be able to deploy this on this node? That's a lot of back and forth overhead between the scheduler and the registry that I don't know they really want to do. And to Sam's comment there, they might not have access to. So, I mean, thinking about that, how does that affect the direction that we might want to consider going here of what options are valid, possible, usable, and whatnot? Because for image selection, we're assuming that's all at the runtime. They just received it and they're forced to pick something out of the list or reject it. But when you're the scheduler, how do you pick which node to go against? If we've got configs, if we've got refers, if we've got stuff dumped in the index, if we dump in the index, right now it's a free-form string in that annotation. If we put it as an annotation, that free-form string is a configuration in something like containerd. The scheduler doesn't necessarily know the configuration of every containerd instance unless there's some kind of return, an NFT or something like that, that pulls that data up to the scheduler so that it knows where it's able to run in. So there's a lot of back and forth in here that probably gets outside of some of our, at least my experience.
Tough topic.
Did we address Derek's question, which is in the chat?
Which one? Your question about the config or
the one with the use case clarifier.
use case for which?
Um,
What's the use case for artifacts? Is that what you're saying?
no, I mean, I think maybe we can just read it out. Derek, do you want to speak to this or has he dropped? I think Derek dropped. No, he's here.
For my point or what?
Yeah.
I mean, I guess what I'm saying is if there's a specific artifact type that's primarily to be consumed by the scheduler or at the control plane level, then that doesn't necessarily need to be defined here just because it's an OCI artifact.
Yeah, but in that case, because the artifact reasoning is not only because of Kubernetes itself. So for our use case, for telco use cases, we just want to need some kind of information about image requirements. We can pull and provision clusters which are not necessarily Kubernetes clusters, where control plane are not necessarily involved in that. The whole idea of this is just to define in more standard way the image requirements from the OS perspective and hardware perspective. HPC comes with this Kubernetes scheduler use cases, but it's not the main use case, I would say. From my own perspective, it looks like after speaking to several people at KubeCon and also at HPC conferences that they would like to define these requirements in more standard way, have some well-known labels about what container requires from kernel perspective, from some, I don't know, hardware perspective. And OCI sounds like a good place to come up with the standard, compatibility standard, right?
Did
Because
you guys consider the discovering of the requirements issue?
no.
How do you know a particular binary that that's in a layer has any of these requirements? Is that an SBOM kind of thing, or I know, Brandon. I'm just trying. It's the same kind of problem. How do you discover the dependencies and?
If I understand your question correctly, if you are building your image and you put it to registry or something like that, or maybe you are the image author or something, or application author, you know the best your container images requirements. So you create this artifact yourself based on the standard. We can come up, and others, the consumers, they know what kind of requirements you have, what kind of requirements the image author put in there.
Right. Well, I mean, I know how to capture capsys type stuff that we need, right?
Yeah.
Just
It's
turn the trace on and then create a list.
Again, like,
Yeah.
it's
I
like
was
this.
trying really hard to avoid having it automatically discovered because I didn't want to overfit on saying every container image needs to have the exact environment that's being used in GitHub Container Registry builders. So I was looking at probably similar from what Marcin was saying, was that this would be the person running the build would inject that configuration into it, saying this image that I'm building, make one for ARM64, but also make one ARM64 that requires this extra stuff.
I think Derek's can go next.
I guess my other point around that is like, is there any information that we'd expect here that wouldn't be in the image? Because that would be somewhat concerning for me as well. Like, if there's basically like whatever artifact that's used by the scheduler, whatever information it needs, it should be able to be derived from the image. So like, even if we were to or have an artifact type, it shouldn't contain information that you couldn't just recreate from the image config itself. Like I think relying on like build time to have some sort of like extra information that gets uploaded, and then like if that gets lost then it's gone forever. I don't think, like, I guess the way I could see it is all the information that's needed to generate this information that the scheduler needs is in the config, and it could look in there. If that's not efficient, then the scheduler could pull it up into whatever sort of like node selector criteria that it has. And that could be Kubernetes specific, or it could be HPC specific. And if it's not available, then information could be derived from the image itself.
That makes sense. Why not just put in the config for the image itself? Why require an artifact to have additional details?
Or make sure that there's, if there's information that's being lost in the config today, then I think that's a problem as well. Like if there's specific requirements or information that's relevant to an image that's not there, then Like that's something we should look at, I think, in the image spec.
So for instance, if I understand you correctly, I put a link into this 6-win router, and in the image config, you would put all this kernel configuration information required, capabilities, and so on.
I would think that that should be there. If there's specific requirements for an image, I think that should be in the image config. Even if that's not used directly by the runtime spec. I mean, there's a separate runtime spec and the image spec is higher than that. Like the scope of the image spec doesn't have to be just to generate a runtime spec. The scope of the image spec could also be to generate this node selector information.
And that would be fine if we can extend the config with all of this missing information. But I'm just worried that I'm not sure if this is a valid concern, that index would grow like much more with a lot of information. That, for example, you have a lot of image manifests that have duplicated entries, and everything is in the index. So you will have a lot of metadata that would have to be pulled. Not sure if that. I'm not sure if there is.
Why in the index?
Sorry, image. Maybe this is lack of my knowledge about image spec in that case.
Yeah, I think he's talking about image config information for the image that is
So
being
it's not
referred to by the index.
Okay.
And I
Okay.
think your point though, I think is possibly valid insofar as we have the platform fields that are different, possibly per image. But we may not have enough, tags for enough images to explain why the config would be different per platform. I think that's part of what you're talking about.
Yeah.
So Derek, I mean, it almost sounds like one field within the platform literally could be, this is going to be like throwing a dart, could be the SHA of the config. And if there were multiple SHAs of, different configs or whatnot, then at least you would know that this is some kind of a selector. And you could pull the config while you're doing the platform check. I mean, you don't really need that, right? You could get that anyway from the image you're referring to. You just pull
it's circular since the platform is also part of the config.
That's right. You're right. It's circular. So really, it just would be, along with platform matching, you could config match.
I guess what I was just thinking is like, okay, here's like a hypothetical scenario. When you're going to do your deployment of say a pod spec, you have images and there's specific node requirements for that. You could have the kubectl or whatever tool is pushing out that spec to the cluster to go and like pull out the node selector information and include that as part of the spec. I'd expect that to be like a little, well, that's just like a hypothetical scenario. So like, you don't even necessarily need an artifact or have the controller itself pulling from the registry, but you could have when you're actually sending these up to the control plane itself, basically push that down to the client as like, hey, if these images have special requirements, that you can pull those up and put those into the format that's relevant to the control plane rather than like, the expected control plane to look all the way down.
Yeah, I mean, we're calling them device claims, essentially, or at least for the DRA process we're going through right now, where basically if a type of device claim is supportable and it hasn't already been allocated on the node, then the scheduler would be able to derive that information from the pod spec that this pod is going to need this kind of device. And that kind of device is going to be something that would be required, right, in a platform spec. A platform that has this device with these capabilities, this specific type of device, configurable device, or configuration of the device, right, like sliced or, separately allocatable GPUs, 2 or 3 of them on the host.
But I'm not sure if I understood everything correctly, but is it not a little bit too late? So for example, you have 3 images in the index. One of them requires GPU. If you are doing this with the image config, you put this information about the image, about the GPU in the image config. You might have from the container the image selection algorithm, you might have a wrong image, wrong manifest. That for example, you because you return always the first that matches, right? And
Exactly. The two-way problem. The top half wants to know all the information about the bottom half so he can schedule, right? And the bottom half wants to know everything about the top, what the top half wants, the scheduler wants, right? But it doesn't have that. It doesn't have any of the information, none of the policies. So yeah, we've got a little bit of problem. We've got too much separation concern without any upward mobility of any upward device information, and not enough downward device information coming in. Sorry, Brandon, go ahead.
I was just going to jump in with a time check, and I think the only other agenda item on here was the Squash FS, which I'm guessing that was Rom. Are you good with chatting about that next week, Rom?
Yeah, that's perfectly fine. Yeah. So I mean, this is about the image spec performance improvements. Just people are weighing in on this issue. So feel free to go and read up on this, I guess. Yeah, next week is fine.
All right.
So I just wanted to actually show a demo of this because nothing more convincing than working code. So, but it's okay. We can do it next week.
Yeah. Didn't mean to completely push you off, but I also thought that this was a good conversation to have our one we've been going through. So thank you, Mike, Derek, Sajay, everybody. Whole team here has been chatting a whole bunch, and I've got a whole bunch of Zoom notes that I'll throw in our meeting notes as well. So
just
appreciate everybody for that.
A few words from me. If you don't mind, I would like to continue the discussion the next week. The basic problem is we need to have a standard way of describing image requirements. It doesn't have to be artifact. Artifact sounded good from my point of view, but if you have a better idea, yeah, it would be great. So maybe let's discuss this as well the next week.
Yeah, and you won't have me on your Monday meeting, but I think you've got some ideas of things you might want to chat about in there without me. So
yeah,
go for it. All right, all. Thanks everybody for staying a few minutes late. Thanks for all the great conversation. See you next week.
Thank you. Bye.
Yes, I really like this, Morrison. I like that it's trying to resolve the problems at the bottom end in a way that it can be useful for Docker clients, nerdctl, Podman, right? But without having somebody else make these decisions at the higher levels. It does make sense to at least have some infrastructure for handling these kinds of filters at the container level as well, especially when it's not running in inside of somebody else's system that's already making that decision. I just want to make sure that we're doing it in a way that is exposed to those systems so that the top end can make the decision first before it accidentally schedules the wrong pod.
Yeah, exactly. So
Right.
we gather a good amount of stakeholders, so people are interested in that. So let's keep talking and see about the outcome. Okay, thanks.
Yes, sir.
Thanks a lot.